That's it? Come on, who finished? What do you guys think of the course? It was hard? Was it hard?
Yeah.
That's good, right? That's what we want to see? All right, first of all, I want to thank you people. All the design judges especially. Some of the design judges came on their own time and their own dime. So definitely appreciate your help. We had a lot of Baja alumni this year, so we hope that the quality of judges really showed that. Next, I want to thank Peter Jones, the SNU system. It was kind of his brainchild, and then him and I and Emily Seaman kind of massaged it to what it was yesterday or the day before. There's going to be forms for you guys to fill out for evaluations. Let us know how we did. If you had any comments, whether it was related to the format, related to the judges you had, anything, let us know. That's the only way the system's going to get better. Unfortunately, the next two competitions are going to be the old way. So if you like that, I guess you might get a couple more. But next year, we're hoping to go to this system as long as the students agree, the advisors agree, and all the rules committee members agree. So, with all that being said, you guys want to know who won design?
Yeah.
All right, we're going to start at the bottom. So, there's 8 design finalists this year, and all of them did very well. We'll start at number 8, which is the University of Michigan, Ann Arbor. I'm going to go through what we liked about each car, some of the highlights, and then at the end I'll open it up to questions or comments or what have you. So Michigan, Ann Arbor. There was a lot of simplicity in design, very lightweight car, a lot of attention to detail. If you look at this car, you're not going to see any like super innovative stuff on it, right? But very simple, well-executed car. That's basically what we want to talk about there. A lot of engineering. When I'm done, I'll talk about overall how all these cars got here as a group of finalists and not just individual cars. So number 7 was University of Louisville. Very similar reasons to being a design finalist. Very well engineered, a lot of completing the cycle. They thought a lot about manufacturing. Again, there's not a ton here that you can say, hey, they did this fancy widget and did this magic stuff, right? Just a well put together, well engineered Baja car. Number 6, Queen's University. All right, Queen's University, similar stuff as I just said. They did some cool stuff in the back end. They had an integrated spool shaft / CV or DOJ is what we like to call it. That was very well done and completely engineered. That's what we're talking about when we're talking about innovation, originality. It's not just, yeah, we have this original idea and we threw it in our car. If you didn't do the work to actually apply the stuff you're learning in school, then you're not really going to get any points for it. All right, top 5. 5th is Rochester Institute of Technology, RIT. RIT did some great stuff. Great use of a data acquisition system that they developed, not just some off-the-shelf thing that they threw on the car. They did the work to develop it. We really like that. this car was one that was really team developed, packaged. Overall, they had a good philosophy. Number 4, Tennessee Tech. One of the big things on their car was the work they did on their active diff, flash, traction control, and some magic stuff in there that's electrical that I don't particularly understand. So, again, well-engineered, well-manufactured car. A lot of good engineering in it. Obviously, they had some problems. Don't beat them up on design on that. You get points for endurance in every dynamic event, and then you get points for design. So you're just going to build the car and compete in the dynamic events, you're going to get points for that. But design points are for engineering. All right, down to the top 3. Number 3, car number 27, Oregon State University. A couple of the things they did, those of you that are running gauge CVTs might know the issues. One of the things they did was they modified that. They really understood how the CVT worked and what to do to make it better. So they modified that. They went above and beyond really any team that we've seen in terms of completing the cycle on components. So it was, they were able to pick a design for the entire car, not just piece by piece, the entire car, made everything work together, and then from that, they had decision matrices and real reasons for picking everything that related to their design philosophy. And from there was a lot of analysis, whether it's hand calculations, finite elements, and they were able to explain how they chose their loads. And then once they did that analysis, they were able to connect that back to something real. They tested it, they validated with some data acquisition. So there was a lot of work on real stuff that we do in the industry that you haven't seen a lot of on Baja FD cars. They did some really good work on their shocks this year, understanding each of them. So that was another feature that we liked. Number 2, Cornell University. The car is called 40 plus. All right. So one of the things that we really liked about this car was their ability to lose weight this year. Not just the fact that it was lightweight, the fact that they lost like 80 pounds or so. That is a huge deal. I don't know what that is in percentages off the top of my head. A lot, right? They were 380 something last year and the 308 this year. In 1 year, that is amazing, right? So that alone was a lot of what we really liked. And when they did that, there was a lot of good analysis that connected to it. They didn't just design a lightweight car, they actually analyzed it and engineered it. They have a nice display. I mean, that's one of those things that goes above and beyond what you need to do. That's a benefit for the team and benefits for the driver. The launch control / shifter on their CVT, they also did a bunch of good work on that that we really liked. All right, that means University of Maryland, Baltimore County for number 1. All right, big thing here is they designed their own CVTs. Drive-in driven in 1 year. It's a pretty big deal. Anybody that's tried to do that, it takes a lot of work, a lot of understanding to get there. Now they did base it on some previous designs, so take that as a consideration in the future. It's not undoable. There's not a lot of CVTs out there that are designed for these kind of vehicles, so there's no opportunity there. and they took that and ran with it. The next thing is their hydraulic sway bar, if you will. They got some fancy acronym they call IPAT, but I don't know what that stands for, so I'm not going to pretend I do. What does it stand for?